Hello everyone, and welcome back to Band 7101 Business Analytics. In this module, we're going to introduce you to data mining. This module's learning objectives are as follows. So after this module, you should be able to define data mining as an enabling technology for business analytics, describe the objectives and benefits of data mining with respect to decision making, identify the wide range of applications of data mining, and identify and characterize the main types of data mining analysis. So what exactly is data mining, and why is it so important in the field of business analytics? In an intensely competitive environment, organizations will do anything they can to get a competitive advantage. And at this point, many organizations are sitting on mountains of data that they know can be leveraged to find patterns and detect insights. Fayed et al. Defined data mining in 1996 as the non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data stored in structured databases. The keywords in this definition are process, non-trivial, valid, novel, potentially useful, and understandable. So data mining is a process. It is a process that requires iterative analysis and sometimes refocusing on particular parts of the data or reformulating a question that the organization has when performing the data mining process. The process of data mining is non-trivial in the sense that each of the different techniques in the data mining toolkit require great thought beforehand to actually figure out what it is you might be looking for. It involves the segmentation of data into appropriate partitions, and it is a process that can require intense analysis. So data mining is not something to be taken lightly. It is a non-trivial process. In terms of the patterns that we are looking for when we are data mining, we need to make sure that they are valid, so that we're not just seeing some kind of correlation between factors in the data that actually have nothing to do with one another. I think the example I used in class before was that there is a website that lists all kinds of silly correlations, including that there is a correlation between the number of movies Nicolas Cage has starred in a particular year and deaths by drowning. So this is probably an invalid pattern. So we are looking for valid patterns in the data that we can make decisions off of. We often hope to find novel patterns, so as yet undiscovered insights. Perhaps there is a correlation between a specific time of year and a specific product that is being purchased by a specific segment of people, and it has yet been undiscovered. So we do hope to find novel insights. We also hope to find patterns that are potentially useful, so patterns that we can actually make decisions off of and make changes in an organizational process or target a different segment of people in order to improve results. And finally, we hope that the patterns we find are understandable, that as a human being participating in a specific organization, that we can understand what we are looking at. And in the context of business analytics, the purpose of data mining, we are always trying to figure out how to improve our decision making. So if we engage in this process and look for non-trivial, valid, novel, potentially useful results that we can understand, we can then apply them in our decision-making process. There is a discussion of data mining as a misnomer, in other words, that it is not the most appropriate name for the process. When you are looking for gold in dirt, you are engaging in gold mining, so you're mining for something valuable that you're looking for. When we're mining the data, we're really looking for knowledge or patterns or insights. So perhaps it should be called knowledge mining or knowledge extraction, pattern analysis, knowledge discovery, information harvesting, pattern searching, or data dredging. But the term data mining caught on, and thus is what we still use today. You've likely already heard of the phrase data mining, and perhaps you've heard it associated with multiple disciplines. And this is because many of the techniques that data mining uses come from multiple disciplines. So data mining pulls from management science and information systems. We have expert systems that help us make decisions, and decision science has informed the process of making those decisions. There are statistical techniques that are considered data mining techniques. Artificial intelligence has emerged over the last 30 or 40 years as a way of finding insights and learning from data. Similarly, machine learning and pattern recognition has aided in this as well. Basic information visualization can help us formulate the questions that we have when we are going through the data mining process. And finally, of course, we're pulling data from somewhere, and so the disciplines of database management and data warehousing need to be drawn upon for the process of data mining as well. I'm not sure if you remember the case of the company Enron. Enron engaged in many illegal activities, including that of rerouting power in the western United States, and it provides an important email corpus for the purpose of linguistic analysis. So the corpus is available here if you would like to check it out. It essentially is the text of all of the emails that were sent to and from members of the Enron organization. And much work has been done in the area of classification in terms of, for example, can we run a classifier to detect who in the Enron organization was part of the in-group, so the people that knew all of the illegal activity that was occurring, and who is in the out-group, so who was not aware of the illegal activities. And these classifiers have been able to predict with very great accuracy based on training on the emails in the corpus. They can then classify new emails in the corpus as to whether or not the sender was part of the in-group or the out-group. You can see the social network generated here along with text of emails and different color codings to indicate what kind of text was involved in the analysis. It's a really interesting case, and it's a great application of data mining, specifically classification, so I encourage you to check it out if you are interested. So what are the characteristics and objectives of the data mining process? In an organization, the source of data for the data mining process is often a consolidated data warehouse, although that is not always the case. The data mining environment is usually a client server or a web-based information systems architecture. And of course, data is the most critical ingredient for the data mining, which can include soft or unstructured data. So data preparation is often a process that needs to be engaged in before the data can actually be mined. The data miner is often an end user, so someone who is in the organization looking for insights. And we talked about finding novel patterns in the data, so striking it rich, in other words, finding something that's really useful and understandable, as well as novel, requires creative thinking. So you may need to do some visualizing first before diving deeper into the data, or just have the ability to call upon your intuition and look for insights in a new way while you're performing the data mining tasks. And so, of course, any tools that we work with need to be able to find the insights we need and be easy to use as well. So in data mining, we're looking for patterns in the data. So what do we mean by a pattern? Well, we're looking for mathematical relationships among data items. And there are 4 types of patterns that we consider in data mining work. The first is that of association. So are there records in a data set that can be associated in some way that is unique? The beer and diapers association is a prime example of this. Prediction is also a type of pattern. So we already looked at prediction in terms of regression, which can fall into the data mining category. Based on past events, can we predict what's going to happen in the future? Or given a new data point, can we predict some outcome based on what we have seen before? We're also going to perform clustering, looking for patterns. So can we segment, say, a group of people in a data set into different clusters that we can then define and, say, target in specific ways? So this could be something as simple as we find that people who are in different age groups are attracted to different types of products, and we perform data mining to detect these groups and then act upon that pattern that we have found. The last of the types of pattern is the sequential or time series relationship. So in other words, is there something that occurs and then a pattern where another event happens directly after it, or that it is likely to happen? So, for example, when Halloween approaches, we notice that there's an uptick in costume sales. Here is a visual representation of the data mining techniques that we just mentioned. So you've got prediction, association, and segmentation as your data mining tasks and methods. Within those general data mining tasks, you will see that there are specific methods. So for prediction, we have classification, regression, and time series analysis. For association, we have market basket analysis, link analysis, and sequence analysis. And in the segmentation category, we have clustering and outlier analysis. So in this course, we are going to visit several different algorithms that are related to classification, regression, and clustering analysis. So specifically, we will take a look at decision trees, neural networks. We've already taken a look at regression, and we will discuss k-means as well. This taxonomy gives you an idea of the different kinds of data mining tasks, the methods that are classified under those tasks, the algorithms that can be used to perform each of those methods, and the type of learning that that method entails. So the two different types of learning being that of supervised learning and unsupervised learning. In the supervised learning case, we go in with specific ideas of what we are looking for and feed those into the model. So for example, if we're looking at the Titanic data set and we want to develop a decision tree that classifies based on different demographics in the data set, whether that person is likely to have perished or not on the Titanic, then we are supervising that learning process. In contrast, if we are performing a k-means clustering analysis in Tableau, that is an unsupervised analysis. So we simply feed our data into the model and see what happens. We have no prior idea of what we want to be in each cluster. Data mining is a large umbrella term, and so it is not limited to those patterns that we just previously discussed. It can also include time series forecasting, so taking a look at time series patterns and then predicting patterns, say, in the economy based on what's happened in the past. Visualization is also part of the data mining process. It can be used simply to inform, say, how you're going to supervise a classification task. It can help inform the data mining process by letting you know what you might be looking for. One question that commonly gets asked when talking about data mining is there a difference between data mining and statistics? Are they the same thing? What is the relationship between the two? And so I would say that statistical techniques fall under the general umbrella of data mining. It can be looked at that way, but we can also talk about statistics as having assumptions heading into analysis, so that you are making a hypothesis, you're testing a specific hypothesis and hoping to get a specific result. Whereas in data mining, sometimes you are just exploring the data with only a general idea of what you're looking for. So I don't think that they're terms that can be used interchangeably, and statistics can be viewed as a type of data mining, but data mining can also be looked at in contrast to statistics based on what kind of assumptions you have going into your analysis. There are many different applications of data mining in different functional areas of an organization. So I won't go into all of them in detail here. You can check those out in your textbook, but we'll provide a brief overview. So in terms of customer relationship management, you can make sure that you are getting a maximum return on a marketing campaign. So, are you targeting the right group with the right product based on what you found in your data mining analysis? You can use data mining to find out what is keeping customers and which customers are your most valued customers. You can use different techniques to identify those customers and then figure out how you would like to retain them based on other patterns. In banking and other financial organizations, data mining techniques can be used to automate the loan application process, to detect fraud, which is a very common application, to maximize customer value, and to optimize cash reserves with forecasting, so using some predictive analysis there. In retailing and logistics, the data mining technique of optimization can be used to optimize inventory levels at different locations based on what different desires are. It can be used to improve store layout and sales promotions. So, for example, Best Buy has heat maps of where customers travel in their stores. They have used devices attached to carts to measure the hot spots in the store and figure out which products need to go in those hot spots. Retail also optimizes logistics by predicting seasonal effects, so already mentioned Halloween, and data mining can also be used to minimize loss due to limited shelf life. In manufacturing and maintenance, data mining can detect patterns that might indicate when and where machines might fail. So we know that there will be some failures, but data mining can help us identify exactly what patterns we're looking for in order to detect those failures. Data mining can also be used to identify anomalies in production systems to optimize manufacturing capacity. And sometimes it's just a matter of discovering novel patterns to improve product quality. In brokerage and securities trading, prediction and forecasting are used heavily to detect changes in price and the direction of stock fluctuations. There are often collaborations between data analysts and people in finance to make predictive models of the stock market. And of course, we've already talked about fraud detection, but data mining can be used to identify and prevent fraudulent activities in trading as well. In the insurance field, again, forecasting can be applied for the purpose of better business planning. Optimization can be used to determine optimal rate plans and to market to specific customers in an optimal way. And again, you have fraud detection as one of the main applications of data mining. And there are many, many more applications in different fields for data mining. We're always looking for novel patterns that can be used to make interesting decisions for either the benefit of people, say in healthcare, for the improvement of profits in an organization, for the purpose of gambling, so even detecting patterns in sports, trying to predict, say, the results of the Super Bowl and placing bets. The list goes on and on. So let's talk now about the data mining process and the different types of ways in which it's been formalized. So let's talk now about the data mining process and the different ways in which it has been formalized. The formalization process has resulted from essentially people gathering best practices in data mining and putting those together. So we have several systematic ways in which we can conduct data mining projects and move from art to science in data mining projects. So we've talked a little bit about business analytics as both art and science already, and there is an art to data mining in terms of the creativity necessary to detect interesting patterns. And we also have a formal process for these projects that can be considered the science of the projects. And depends on who you talk to, everyone has a different data mining process. So there are 3 common standard processes in industry, and we'll talk a little bit about each of these, but as you're working in analytics, you will find that you'll develop your own process and figure out what works best for you. So the most common standard processes are the CRISP data mining process, SEMMA, and KDD. So let's first talk about CRISP data mining process, so the cross-industry standard process for data mining. This was originally proposed in the 1990s by a European consortium and is composed of 6 consecutive phases. So the 6 phases are that of business understanding, data preparation. So this first half of the process is said to take about 85% of the total project time. I can attest to this. Really understanding the business and the data and preparing the data, these are going to set you up the actual data mining process, which if you're just applying the algorithms or using the tools, that piece can actually be a lot simpler than the preparation work that is required. If you, of course, already have a data set that's pre-prepared, say one that you've pulled from the internet, then you can typically spend some time on step 2 and don't need to spend any time on step 3. You can move right to the model building process. Once you understand the business context and the data set that you are choosing and have prepared, you can then move to model building, the testing and evaluation of your model, and then finally the deployment of your model for the purpose of actually mining patterns and making decisions using those patterns. Here is a visual model of the CRISP data mining process. So moving from business understanding to data understanding, data preparation, model building, testing and evaluation, and finally deployment. You can see that data is at the center of this process. The outer arrow indicates that this is an iterative process that can be highly repetitive. Maybe you found something in your model building that increased your understanding of the business or that increased your understanding of the data, and that now you can prepare it in a different way and build a new model. So it's really not a one and done procedure. Typically, you're going to refine the data that you're looking at in the process and then build new models to find new patterns and test those as you go. And so you can see these red arrows indicating that yes, after you have tested and evaluated your model, perhaps it's increased your business understanding, so you move back to that step, or perhaps it increases your understanding of your model, so you tweak the model. Maybe you re-prepared the data, which increases your understanding of the data and increases your business understanding. So these are all processes that can take place in an iterative and repetitive manner, as well as can inform each other and skip around a bit. So it's really going to depend on the context of what you're working with, the specific model you're building, the insights that you're looking for. This is just a very loose, general formalization of the process that as you work on projects of your own, you'll find is a fluid process and you'll find what works for you. The SEMMA process is similar. So this is another proposed formalization of the data mining process, where first you sample, so you generate a representative sample of the data. So some little piece of the data that you can explore in order to see what you really want to do. So once you have your sample, you then move to the exploration process. So you maybe create some visuals and get a basic description of the data based on that sample. Once you're satisfied that you have a basic understanding of your data, then you can modify. So you can select which variables you're actually interested in and transform variable representations as needed in order to build your model. At that point, then you move to the actual analysis. So the modeling, where you can use statistics or other machine learning models in order to look for patterns. And then assess, so evaluate the accuracy and usefulness of the model that you have. And again, you see these arrows that each step informs the previous step. So you have this constant feedback loop, and that it is an iterative process until you decide that you've found, what you're looking for. Finally, we have the formalization that is known as the Knowledge Discovery in Databases process, or KDD. You start with your raw data and first select your target data. So pull the data that you're actually interested in mining. The data will need to be cleaned typically if it's coming from a raw source. So after you've pre-processed your data, you may need to transform it in order to feed it into a modeling tool. So for example, Tableau has different requirements than Excel. Depending on the type of analysis that you're doing, you may need to transform the data in order to fit the tool or the model that you're going to build. After all of that preparation, then you engage in the actual application of the data mining algorithms and uncover the patterns that you may have found. Each of these steps, just like in the other models, can inform previous steps. So maybe you find a pattern and you want to know more. So you gather more target data, you reprocess it and transform it and get more patterns. Once you are satisfied with the patterns that you've extracted, then as an analyst, you can take time to internalize those patterns and figure out how they can be applied in the organization that you're working in, so that you actually have knowledge. You have now an actionable insight from the data mining process. So this is data that was a survey ranking of data mining methodologies and processes from kdnuggets.com. This graph I'm just showing you to illustrate that many people out there actually consider their own data mining process to be the best process. And so, we do have these formal processes like SEMMA and CRISP data mining and KDD. Organizations have their own specific process, but as you really start to hone your skills in this area, you may likely develop your own data mining process, which you follow in order to get from raw data to actionable insights. So I encourage you to keep an open mind, not to just glom on to one of these specific formalized processes, and start to think about, how am I going to play with this data? What do I need to do? What am I looking for based on what I think about this data? What am I looking for? How do I need to organize the data in order to get there? And with practice, you will find your own way. There are many data mining software tools on the market, some of which are free and some of which are not. So IBM has many different statistical tools as well as optimization tools on the market, including SPSS. Alteryx is also a very popular data mining tool. In terms of free and open source tools, we are going to be using RapidMiner in this course. It's great for learning as well as actually conducting data mining analysis. Python and R have really emerged as popular programming and statistical languages that are free and can be used with different packages to conduct data mining activities as well. And there are also specialized tools like Weka that can be used to do linguistic analysis. So you really have different tools for different purposes. You have visualization tools like Tableau. You've got programming tools that can perform multiple types of analysis. You have statistical tools like SPSS and even just plain old Excel that can be used to conduct data mining analysis. And then you have more specialized tools like Weka or specific packages in Python that can be used for sentiment analysis, for example. If you're not sure where to start, I recommend doing an internet search to take a look at which tools are available in which area, and then go from there to see which is best suited for the project that you're working on. There are many data mining myths, so we'll take a minute here to debunk those myths. So the first myth is that data mining provides instant crystal ball-like predictions. If you're lucky, perhaps, you get output from whatever tool it is that you're working in that immediately makes sense to you and that you can immediately move forward with in terms of decision making. But the reality is that data mining is a multi-step process that requires deliberate, proactive design and use. So one cannot simply throw data into a tool and hope to get insights from that data. You really need to know a little bit of what you're looking for, or at least know the structure of the data and how the tool can be applied to the data before you're able to actually get insights from it using one of the analytics techniques. So it's a thoughtful process and it's an iterative process. It's something that you'll need to refine as you're working with your data set. So again, you can't just take a data set, throw it into a tool, and hope to get something out of it right away. Second myth, so data mining is not yet viable for mainstream business applications. Well, you probably know intuitively that this is just not true. So there are many state-of-the-art tools already ready for just about any business type or size. So if a business has data, there's generally some analytics tools that can be used to get insights from that data. Another myth, so data mining requires a separate dedicated database. You can use a separate dedicated database, but it does not require the use of one. So because of advances in database technology, a dedicated database is not required. The next myth, so only those with advanced degrees can do data mining. While it helps to have the skills perhaps taught in, say, a business analytics program, in order to be able to interpret and kind of work through the process, there are now newer web-based tools that enable managers of all educational levels to do data mining. So they might not be able to do highly sophisticated analysis and kind of refine process as they go, but they can definitely at least get started in the data mining process. And finally, data mining is only for large firms that have lots of customer data. Well, this is simply not true. It doesn't matter how much data you have. As long as the data accurately reflect the business or its customers, any company can use data mining to get insights. And finally, let's take a look at some of the mistakes that can be made during the data mining process. There's a lot that can go wrong because it is both an art and a science. So the first is that really you've selected the wrong problem for data mining. So that you are trying to solve a problem that looking for insights hidden deep within your data is not going to help you with. Perhaps it's something more suitable for just intuition. Maybe it's better to ask experts in the field, but for whatever reason, the problem you've chosen is not a problem that can be solved using data mining. Another mistake, so if you ignore what your sponsor, whoever wants you to perform the analysis, thinks data mining is and what it can really do or not do. So there might be some confusion that data mining, can do all sorts of things. It can find great insights and immediately improve profits. That's just not true. It's a very involved process that requires a lot of thinking, and we are limited to the types of analysis that are available and the tools available to us. And there might also be time constraints given the amount of data that you might have and the processing time that it takes. So you really need to be upfront with whoever's asking you to perform analysis, about the limitations that the tools and the data may have. This third one, so beginning without the end in mind, this is a critical mistake. So even in data mining, when you maybe aren't making too many assumptions about your data, you need to have some idea of what it is you're looking for going in. So you can't simply go in blind. You need to take the time to understand what your data set is, the different kinds of fields in your data. So, those will help you understand which types of analyses you can actually perform and not perform, as well as what kind of question are you trying to answer? Are you trying to segment populations in your data? So do you need to apply clustering technique? Are you trying to classify things in your data? It really depends on what type of outcome it is that you're looking for. That'll inform how you need to format your data, what type of data you need, and then what types of analyses can actually be performed. So there is a process through which you can make sure that you at least have some idea of where you're going and then work backwards from there. The fourth one, so not leaving sufficient time for data acquisition, selection, and preparation. I think that especially from a student perspective, where you've often been given pre-cleaned data sets that are easy to work with, and you're told specifically which tool and which analysis to do, that there may be some misunderstanding that real world data will be in the same format and will already be easy to analyze. So, and it may be that you have data pre-cleaned for you and that's able to be just kind of plugged into a tool, but typically this won't be the case, especially if you're working at a higher level within an organization. So you'll have to budget that time to actually get the data needed to do the analysis, to select the specific features and maybe the records that you're going to use, and to be able to prepare that data for analysis. And that really is a time-intensive process if you're just given raw data or access to a data warehouse. And there are other mistakes listed in your text that I encourage you to go look at. This last one that is mentioned, so the mistake of looking at only aggregated results and not at individual records or predictions. So sometimes there might be something that you miss in, say, summarized data that you would only be able to see from looking at individual records. So when you're looking at results, you really want to take the time to go look at everything that's available for you in the analysis, because you don't want to miss anything. So this has been a brief introduction to the concept of data mining, the data mining process and the different components of that process, as well as specific data mining tasks and methods that you can perform. So once your data is cleaned and prepared and you've selected which data you're going to use, you can then implement one of these algorithms in order to look for your results. So in the next few modules, we'll be taking a look at some of these tasks, methods, and algorithms in greater detail so that you can learn how to apply them directly to data sets in specific tools. If you have any questions about these concepts, please let me know.